welcome to What Is It About the Weather, where once a week we get together and explore the many ways that weather intertwines itself into our lives. I'm your host, Mark Jelonic, and this week we're going to seek an answer to the question, would you trade Earth's weather? But before getting into the main topic, as always, let me take a moment and say thank you to all of you supporting the podcast. Whether you're doing it financially, through tweets, through emails, from ideas to communicating with others, whatever way you're doing it, thank you. The podcast thrives because you guys take the time to participate. So I hope some of you got a chance to enjoy the Masters last weekend after we talked about it. Maybe see some of the flowers in bloom. It didn't seem like peak was right as the tournament was going on, but pretty close. Pretty close. A lot of color, for sure. I know we've gone from green rain here in my neck of the woods to more like just plain head-on pollen season. So if you're dealing with that challenge, I know a lot of people do. I know it's tough for a lot of folks. Hopefully you're getting enough rain in between all the other things going on, or some way to alleviate the magnitude, if you will, of the pollen season. I was just looking at something right before starting the recording where the numbers are just through the roof for me where I am today. But I'll persevere. I don't have bad pollen reactions, but I know it does get in there and kind of clog up my head a little bit. It gets tough when there's that much stuff in the air for it not to have some sort of impact. But I know we're supposed to have some nice rain this weekend, and it should clear things out a bit. I tell you, this week's one of those weeks. It's that time of year again here in my neck of the woods. And for anybody who deals with hurricanes and tropical storms, etc., in the Atlantic Ocean, we've entered crazy season. You know, it feels like we just went from a sporting event to a different type of a sporting event, except it involves weather, where the seasonal forecasts start coming out. As well as everybody who wants to interpret those seasonal forecasts. And there's been a lot of stink about a Time article, or more importantly, the headline. So Time wrote an article that says, forecasters are warning this year's hurricane season will be worse than usual. And I've seen meteorologists on Twitter, as well as other folks writing articles about the fact that that's not what it said at all. But, you know, we live in this day and age where people don't read it unless it's some sort of end-of-world headline, the whole fatalism kind of problem we run into, right? If it's not over the top, will you really click on it? Because really what it said was, there's a chance that it's going to be more active than average. But that doesn't tell us anything about where things might make landfall, or if they're going to make landfall. It's just an idea of what the season looks like, and there's still a lot of uncertainty. I had one of my brothers reach out to me this week just to even ask the same things, what my opinion was. And having been in and around tropical cyclone forecasting for a long time, I gave him 3 perspectives, and I'll throw them out there for you. Basically, there's a few different ways you can look at it. You can look at things statistically, as an example. We do this a lot of time with longer range weather. You know, what are really the odds that this year would be as bad as last year? You know, look for examples of what it's done in the past after we've come off a really busy season. What are the likelihood of having another, not just a busy season, but one that's so impactful, you know, with so many large, strong landfalling hurricanes. You can also look at it dynamically, looking at the weather, precursors, you know, what we're seeing now. And you've probably heard before all this talk of El Nino and La Nina and the role it has in the Atlantic hurricane season. And then, of course, you can look at it historically and say, okay, you know, all it takes is one hurricane. You could have a season that's very, very quiet, or a season that's very active, and it doesn't necessarily translate one to another. How do the two relate? So I tend to bundle up those things when I'm giving somebody at least a top-line perspective. I try to give them a view from each of those angles in terms of what I see and what I might recommend. And so I tell you to kind of do the same thing. When you're looking at it, don't, I guess, get hung up in a headline. Don't get hung up in even one forecast. More and more people are doing these forecasts now. Consider the sources of information. How does one compare to another? What are they using their baseline? And I know all that's easy to say. But I would also tell you that most of the people forecasting at this stage would also, if you read their real forecast, because most of the time they do a full forecast, a little bit of a report that goes with it, for now you can see there's still a fair amount of uncertainty. Things are leaning towards a certain way, but that may change a bit too. So just keep that in perspective. All right, let's dive into the main story. Earth's weather. I mean, here we are talking about hurricanes, but is it really all that bad? I mean, we've got tornadoes and hurricanes, and these things kill people, and they destroy property and just cause complete upheaval in countries or regions. They could be devastating. But do you really want to give it up? Do you really want to trade it for what we might see on another planet or another location? Now, the world of sci-fi for a very long time has provided us a variety of ways to get different types of weather, or glimpse into different types of weather. And let's be clear, most of the time, they're trying to paint a picture that helps them tell their stories, right? And this week, a sci-fi series that I like to watch called The Expanse, it's based on a series of books, came out with their new season. And the premise of this whole thing, just to kind of fill you in for those who don't watch the series, involves Earth, Mars, which has been colonized, and the outer belts. So the asteroid belts. As we all know that, we believe someday we're going to be out there kind of getting the resources off of these asteroids. And there have been some times in all this where weather has come into play. Not as big in the series. For the most part, the recognition is you got to have a spacesuit everywhere. And the series has been very focused on spacesuits. But then, as an example, recently I watched a movie, Valerian and the City of 1,000 Planets. And they had some planets with gorgeous weather, sunny, warm, pleasant. Or you can take a movie like The Martian, which was very specific about weather impacts of life. And why you did need to wear that spacesuit going around, why you couldn't just pull it off. And then there's even, we've got these futuristic looking things like the recent Blade Runner movie or the Matrix series in the past, where the Earth's climate, due to our causes, of course, has been left devastated. So you might want to get away from the weather for that reason. So sci-fi gives us all these things. But most often the weather it's giving us, right, is to tell a story, however they want to tell the story. So a lot of times we see weather on planets that may or may not be realistic because it allows people to take their spacesuits off. Maybe they want to focus on the faces and not the suits. Other times, the story may very, very well be about capturing people contained in those spacesuits and the challenges that it presents. But whether it's some big storm rolling in, and again, there's plenty of examples of movies where, they're escaping this brutal storm that's coming. Or whether it's just the background scenery and trying to paint an environment that's either hostile, right, or hospitable, or even pleasant. But it's about storytelling. It's not about reality. Very seldom is it about reality. Sometimes it is. Like I said, things like The Martian, the idea was to at least give you some sense of a reality. But even with all the challenges that Earth weather has, is it really all that bad? Right? Do you really, really want to give it up for what you might see in other places? It's tough to know what weather's like in other places. We have a hard enough time with what it's like here sometimes, right? But we have a glimpse of, let's stick in just our solar system. I've read stories in the past about weather on other planets, light years away, and I think that's a little harder to say with certainty. I know we have in a broad sense, we might be able to detect and understand certain things. But sometimes getting down to what it would feel like for you as an individual might be a bit difficult. So let's stick with some basic stuff. Let's stick right here, close to home, relatively. And before we get into the weather, I just want to throw some size things around just so you can get an understanding. So the sun is a certain size, right? And then we have the Earth, which is about 1% the size of the sun. It's not exactly that, but roughly that. Then you get a moon, which is about a quarter the size of the Earth. And as an example, Jupiter between the Earth and the sun, Jupiter is about 10%. Again, I'm doing a lot of rounding here just to keep things simple. About 10% the size of the sun. So we do have these different bodies in the solar system that are a variety of sizes. And depending on what their structure is and how close to the sun, that great heat source and light source they are, you can have some very different things. Now, some of you might like lack of weather, right? I know some folks just like, give me plain, boring, sunny weather all the time. But be careful what you ask for. Let's take the planet that's closest to the sun, Mercury. Essentially has no atmosphere, little thin atmosphere. I'm not saying none, but for all intents and purposes, it doesn't feel like much of an atmosphere. It doesn't behave like one that we're used to. Lots of heat. It's really long days. First off, its orbit around the sun is about, I think it's a little over, between 80 and 90 days. I don't remember the exact number off the top of my head. And for every 2 orbits of the sun, so for every 160 to 170 days or whatever, it rotates 3 times. So some long days, roughly 55 to 60 days. Again, I don't remember exactly what the number is, but somewhere in that range. Some long days, and those days can get pretty hot. Pretty darn hot. Upwards of 800 degrees Fahrenheit. Or for you Celsius folks, it's a little over 425, a little above that. Nice balmy day, if you will. And then on the night side of the planet, when you sun finally sets, you've cooled off, you got one of your 55 Earth Day days coming, you can get down to about, negative 290 Fahrenheit or 180 Celsius, in that range, if you like that sort of thing. Can be a little difficult to plan for. You don't, here we have these seasons, right? You get seasons and you might change your clothes based on the season or activities for the season. There, I think you got to kind of go to a whole different level of planning, if you will. Switching between those two temperature extremes. Now, much of what drives that change in temperatures, part of it's facing the sun versus not, but part of it is also that lack of atmosphere. So you hear about, greenhouse gases and those other things, but our planet, part of why it maintains a range, if you will, is because it has an atmosphere, because that temperature layer gets captured. And you've probably ever noticed it if you've, maybe traveled to an area where heat more easily escapes because you don't have a lot of clouds or moisture, like a desert area. Get very hot in the day and cold at night. Well, this is just an extreme version of that. And you can even see that in places like the moon, where it can go from plus 200 Fahrenheit to minus 200. And it really just has to do with the fact that there's no kind of protective layer keeping things in, even though it's at the same distance to the sun as the Earth. It's not as simple as just the atmosphere, but it's part of what contributes to that problem. Whereas you might look at a planet like Venus, not as close as Mercury, and it has these nice long hot days that are about 800 Fahrenheit. They gotta hang out there. And because it's so hot, you're actually protected from its miserable sulfuric acid rain that never reaches the surface because it evaporates. I mean, at least you have that going for you. It rains. It rains stuff that would, eat your skin off. But for the most part, if you're on the surface, you never see that. So it gets gone before it gets to the surface. It's also a very heavy atmosphere. I don't know. I can't, that's kind of one of those things where, can you imagine it? Anybody who's ever spent time in humid places knows how it feels heavy, even though it's not really. But can you imagine just the air feeling heavy on your body? I don't know. It seems sort of weird to me. Now, they do have some winds, but not at the surface. The winds are higher up in the atmosphere. So you're going to just be there miserably hot with no cooling wind and just feeling stifled from the pressure on your skin. Then again, you really wouldn't be able to be out in it because it wouldn't be a safe environment to breathe. But let's just assume for a moment it was. So then we shift to Mars, right? Because we saw the movie The Martian, or we see, other things Mars talked about a lot. Smaller than the Earth, thinner atmosphere. So again, it can't really hold the heat. And some days get up to about 80 degrees Fahrenheit, but the nights get a little bit chilly. No rain. Again, we don't have any moisture to work with. Lots of dust storms. So there are comparable areas on Earth that deal with that a lot of the times. And for folks that are used to that, Mars might be a great fit for you. Again, for me, I don't know. But with all this talk of going to the Mars or going to the moon, you start to wonder, what would it be like in comparison? And there are places on Earth that similar conditions exist, at least for parts of the year or parts of a day, that you could kind of equate to what it would be like there. Maybe not the nighttime cold, but certainly the daytime heat or temperature levels, the dust storms, the dry, arid conditions. So maybe those are the people that need to sign up for the trip to Mars. I've always thought, wouldn't it be cool to go to Mars? But I think the weather would bore me. Maybe some of the other parts of it would be cool. Same thing with the moon. I think I'd hit the moon, I'd be very frustrated. I'd be looking down at Earth going, ooh, look at that storm. Ooh, look at those clouds. Ooh, look at that lightning. I never thought about it. I wonder if I could see. I'm sure I could probably figure that out by looking out there. If I could see lightning. I know we can from some satellites. We monitor lightning. I'm wondering if from the moon at night I could see a lightning storm. I would hope so. But then again, like I said, I think I would get very, very envious of the people on Earth enjoying the weather. But you look at those inner planets, and generally you say, okay, there's a lot of non-atmosphere. The moon, Mars, Mercury, there's just a lot of not weather going on, if you will. Venus is really the exception, close in, besides Earth. So how about those wild storms we see in the sci-fi movies or whatever it is? Do they really exist? I mean, are those things just made up? Or is there some baseline? And we can move out further in the solar system and get a sense of that, right? Jupiter's a planet that's captured us for a very long time, and it's because it's got that big red eye, that storm that spins around and around. It's got strong winds on the outer edge, right? Probably twice as strong as a really intense hurricane on planet Earth. But the winds, interestingly enough, the strongest winds are around the edge. And it has to do with the fact that this is actually not even a low-pressure system at all. It's actually an extremely high-pressure system. You don't think about that much. You don't think about seeing the spin, but it's in its southern hemisphere, and it's spinning counterclockwise. So it's actually an anticyclone, as we call it. But Jupiter, in a broad sense, even though, I always laugh when they talk about the surface of these planets, and what I've read, and I'm not an expert in these things, is they try to say the surface of the planet is where the pressure level's similar to Earth, right? Because most of these planets, these outer gas giants, if you will, they're believed at some level to eventually have something either solid or containing some solid components that would be about the size of the Earth. But realistically, that's more like our core, right? And it is their core. But in between there, you go through these liquid of different, chemicals. It's not just like a water ocean sort of thing. There is some water in some cases. Then through these cloud layers, and you get to a top layer that's very near the outside of what's considered the planet, where you see that spinning red eye, if you will. So up there, if you were able to handle it, right, if the air was actually breathable, which in all these places it's not, of course, you do get things like lightning and wind and swirling clouds that are storm-like, and even aurora-type events. They're just a bit stronger. Jupiter's kind of a doubling in a lot of cases that I read. But you can't be out in it because it's not warm enough. Or it might be hotter depending on how energy is trapped. But certainly it's chemically unhealthy. The cool things are, there are some neat things and all that, right? So some of the places, these outer planets, it's believed that it rains diamonds. It's kind of cool, right? Or helium rain. I mean, you hear these things, and it's hard to imagine because imagining some of these chemicals, which are on Earth in a gas form, being cold enough to get to a liquid form. And again, it would not be real pleasant to deal with. But it's still kind of neat to imagine. I don't know. Imagining diamond rain is kind of a neat thing. And that apparently, again, we'd have to go there to firmly prove these things. But our understanding now suggests that diamond rain on these outer gas giant planets is maybe a pretty common thing. Or you take a planet, you got Jupiter, but take a planet like Saturn, right? You got past the rings, you made it to the planet. Again, you don't really have a place to stand per se, but say you had this nice floating hoverboard. But imagine winds over 1,000 miles an hour. So faster than the speed of sound. But at least they've got these cool, near the pole, they've got this hexagonal shaped rotation going on. And we've seen similar things in storms here. You often think of the eye of a hurricane as being this nice round thing, but we've seen it take different geometric shapes, kind of like those storms on Saturn. And the further out you go, it gets colder and windier. But sometimes you run into cases like Uranus that the heat spilling out. Just all sorts of puns we can go with there. I'm not going to do it. But for some reason, you would think that the further out you go, the colder you get. But it's not always the case. Given the dynamics of a certain planet, it may not be able to hold its atmosphere the same. May have lost some of its heat during some sort of collision with a planet millions of years ago. But however you look at it, these outer planets, one, there's no good place to stand. Or by the time you get to something solid to stand on, you'd be crushed. Two, it moves so fast. Think about rustling winds or just the sound of wind and how part of so many people's lives. I mean, most of us experience wind of some kind on a regular basis, and it's just part of the makeup of our experiences. But imagine the wind moving so fast all the time that it's faster than the speed of sound. Sometimes it's hard to fathom all those things. Any case, maybe what you need to do if you want to experience some weather is instead of thinking about these big planets where you can't even stand, maybe some of their moons. Now, most moons, kind of like ours, just don't hold an atmosphere. But there are a few exceptions. So outside of all these gas giants, many of them have moons that are kind of between the moon that we have and the size of Earth. And Triton, for instance, outside of Neptune, orbiting Neptune, has some cloud clear mix, so you get a little bit of that atmosphere feel. Io on Jupiter has an atmosphere that comes and goes, and it's very much based on the volcanic eruptions. It can't hold on to its atmosphere, but it's got enough internal things going on in the moon itself that it reproduces a new atmosphere, which is kind of a neat idea. But probably the one most like Earth is Titan, orbiting Saturn. Unfortunately, again, it's still going to be lethal given the makeup of temperature and what's actually in the atmosphere. But at a minimum, you'd at least get some interesting Earth-like behaviors, possibly even some rain. The dynamics of exactly what the atmosphere is going to be like a little tricky, but something closer to resembling what we do here on Earth. So just within our solar system alone, we have something for you heat lovers, something for you cold lovers, something for you storm lovers. We've got it all. You don't have to go all that far. So maybe as we start colonizing the planets and the cryogenics get better, you can say, hey, freeze me until we're traveling to X. That's the kind of weather I'd like. You know, I came across a podcast called, I think it's the Astronomy Cast. I'll put a link in the show notes, that had a lot of good episodes, and they broke down weather on these different planets as they've covered them over time. Yeah, it is. It's astronomycast.com. So maybe check that out. And of course, there'll be some other links in the show notes. Where would you? I mean, have you looked at a planet or been captured by a planet and thought that would be really neat weather? Let me know. What is it about the weather at gmail.com? What is it about the weather.com/contact? And speaking of clouds and brothers, I heard from both of my brothers this week about weather-related items. Now, that doesn't happen very often. But my other brother sent me a story about the new clouds that, and we've talked about this a little bit, that were added in 2017, and how seldom we've updated the cloud almanac, if you will. But what was interesting about the story was how it talks about how we have all these ways to capture clouds now with our mobile phones and everything. We're seeing the Earth in ways we've never seen it before because we got so many eyes on the situation. Both our natural eyes, but our ways to capture what our natural eyes are seeing. And we're all looking and capturing these things. And it's helping us be involved, everyone be more involved in the science and our understanding of the planet. So take a look at that article. It's kind of neat, and it talks about how even you could be involved in helping discover cloud types, because actually those cloud types do give us a better understanding of weather that's on the way, particularly important, especially in the short term. And it just makes us more knowledgeable and more aware of all that's going on around us. Well, whether it's putting your head in the clouds, or whether it's dreaming about what weather would be like in another place, that weather's going to have the same. Can you imagine it raining diamonds and the impact that might have on things? Getting things done on that location. So whether here or a planet afar, weather's going to be impacting everything that you're trying to do, right? We all know that by now. Sometimes it's annoying, sometimes even devastating, but sometimes really entertaining or interesting or just enjoyable. So keep your head in the clouds, but always explore what the clouds are then doing to the world around you. Because as we all know, there's much more to weather than the weather itself.
There's your two white sofa production.
We're tired of hearing our uncle grovel, so please support him on patreon.com/weather.